Hello guys, in this video we're going to talk about the homework 12.1 sequence, hard level 5 plus. So for the first questions, they're giving you that the general term Tn, you can using this formula, and we want to find out this whole thing. So which means we have to find out T1, T3, and T8. So we just substitute the 1 inside the n, and then we change the n here to be 1. So try to pause the video and then to try to do it yourself. Alright, so now we can have the T1 is equal to 5 times 1 squared minus 3 divided by minus 1 to the power of 1 minus 1. So this is going to be equal to 5 minus 3 divided by, so minus 1 to the power of 0, this is 1. Okay, so T1 is equal to 2. So for T3, we have 5 times 3 squared minus 3 divided by minus 1 to the power of 3 minus 1 giving you 2. So now we have 5 times 9, you get 45 minus 3 giving you 42 divided by 1. So we have this is equal to 42. And then for the last one, we try to find out T8. So we have 5 times 64 minus 3 divided by minus 1 to the power of 8 minus 1, which is 7. So this is going to be equal to 64 times 5 is equal to 320 minus 3, giving you minus 317. Okay, so for the answer, we just want to times them together. So we have minus 317 times 42 divided by 2. So it's equal to minus 317 times 21. So using a calculator to find out the final answer. So for question 2, we have the general term is equal to Pn, p to the power of n, minus Qn. And we have two conditions, T1 equal to 5 and T2 equal to 13. And the another condition is P is greater than 0. So how can we find it out? So we can just substitute the n is equal to 1. So we have the whole thing is equal to 5. And then for the second one, we can substitute the n is equal to 2. And then saying that the whole thing is equal to 13. So try to pause the video again and then try to think about by yourself. So now we have the T1 is equal to P to the power of 1 minus Q times 1 equal to 5. We simplify it to get the P is P minus Q is equal to 5. And then for the T2, we have P squared minus 2Q equal to 13. And then you can see now we have these two formulas, isn't it? And then we can try to substitute the Q is actually equal to P minus 5 back into this equation. So we have P squared minus 2 times P minus 5 equal to 13. So we have P squared minus 2P plus 10 minus 13 equal to 0. And now we have a quadratic equation. So we can factorize it. So P minus 3 times P plus 1 equal to 0. So we have P is equal to 3 or negative 1. But P is actually greater than 0. So this one should be rejected. So now we have the P is equal to 3. So we have the Q is actually 3 minus 5. Then it's equal to minus 2. So now we have our general term is just equal to P to the power of n. So it's 3 to the power of n minus Q. So Q is minus 2. So minus 2 giving you plus 2n. Okay, so that's our general term. And then they're asking you to find out T6. So T6 just equal to 3 to the power of 6 plus 2 times 6. So 3 to the power of 6 is just equal to 729 plus 12. So the answer should be equal to 741. Alright, so for question 3, we have x is greater than 0, and then we have a sequence like this. So if we observe this sequence, you can think about this as actually in two parts, isn't it? So the first part is just a number, it's a square numbers, and then so 4 is equal to 2 squared, and then 9 is equal to 3 squared, isn't it? 2 squared, 3 squared, 4 squared, and 5 squared. And for the second part, it's just log x, log 2x, just changing the number here to 1, 2, 3, and 4. So try to think about by yourself and then try to find out the general term, pause the video. So now we have the left parts. So for the nth term, it's just actually equal to, you see when this is the first term is 4, so 2 squared. When the second term is 3. So when this is nth term, it just becomes n plus 1. So n plus 1 squared, and then times log nx. So because when the first term is 1 times x, for the second term is 2 times x, for the fourth term is 4 times x, so for the nth term is just equal to n times x, isn't it? Okay, so now we just want to find out the 10th term. So the T10 just equal to 11 squared times log of 10x. The x is just always there, okay? So the 11 squared is just equal to 1 to 1 log of 10x. That's the answer. Alright, so for question 4, we have a general term Tn is equal to a quadratic formula. So now we have the kth term is equal to 49, which means we can substitute the k here. We can set an equation that the tk is equal to 49. So try to substitute this equation by yourself and then find out the value of k. Alright, so now we can do is the tk is equal to 3k squared minus 5k minus 1 equal to 49. Try to solve this by yourself, okay? So now we have 3k squared minus 5k minus 50 equal to 0. So we have factorized it. So 3k and k here. So what we want is two things times together give you negative 50. So you can try this negative 5 and positive 10 here. So double check it. So 3 times negative 5 gives you negative 15. This is positive 10. So this one plus together gives you minus 5, which is correct. This is equal to 0. So we have the k is equal to 5, or a negative number, negative 10 over 3, which is impossible. So this is rejected. So for part B, we need to determine whether this is 151. So if we can find out number n, which can fulfill the final answer is equal to 151, that means it's actually a term in the sequence. So what you're going to do is try to find out Tn equal to 151, and then to solve this, try to find out is this n, the answer finally is actually a positive integer. If we can find out the answer, then which means that it's actually in the sequence. So we can try to do it. So 3n squared minus 5n minus 1 equal to 151. So we can say that 3n squared minus 5n minus 152 is equal to 0. So we can try to factorize it or just using your formula 0, 1. So 3n and n here. And then how can you do that? Maybe we can try to use like, how about 31? Is this going to work? No, 31 is not worked. So we need to think about how can we factorize this 152. So we can divide by 2, isn't it? So now we have this is equal to 76. And then divide by 2 again. So we can have this is equal to 38. And divide by 2 again, we have a 19 here. So how can we find out a solution for this? It's quite hard to using the factorization actually, and well, I think maybe should be equal to negative 8 here. So we have a positive 8. No, it should be a negative 8 here, negative 8, and then this is a positive 19, isn't it? So we double check it. These two times together is equal to 152, which is correct. So 3n times negative 8 give you a negative 24 plus 19. Okay, get you the negative 5. Okay, so now we can say that n is equal to 8 or negative 19 over 3. This one should be rejected. So now actually the 8th term is actually equal to 151, which means that 151 is actually in our sequence. Okay? So for question 5, we have a general sequence like this, and then all numbers should be in real. So try to find out T4, T8, and T10. It's actually just substitute inside it. So T4 just equal to square root 50 minus 4 squared divided by 2. So that's equal to square root 42. And then T8 just doing the similar thing. And for T10 is equal to the square root of 50 minus 10 squared divided by 2. So this is going to be equal to 10 squared equal to 100 divided by 2 is 50. So that's going to be equal to 0. So how many terms are there in the sequence? So just to think about it, it should be real numbers, isn't it? After taking a square root, still a real numbers means that the things under the square root should be greater than 0. So we can say that what we want is just 50 minus n squared divided by 2 should be greater than 0. So which means that n squared minus 100 should be smaller than 0, isn't it? So now we can say that it's actually equal to the critical value should be n equal to 10 and negative 10. So it's actually between minus 10 and 10. So it's in between of minus 10 smaller or equal to n or smaller than or equal to 10. so it's between this range, but actually the n should be greater than 10, greater than 0 as well. So our final answer just equal to n is greater than 0 but smaller than 10. Okay, so the largest term is just be equal to the 10th term. So the 10th term is actually our largest term. So we can't have t11 because the t11 what you get is just 50 minus 11 squared over 2 and taking the square roots. And this thing is already 60 something, which is already greater than 50, but you cannot to take as square roots of the negative numbers. So there's only 10 terms in our sequence. Okay.